final thing. We could spend 1 minute or 1 hour. I'll probably spend 2 minutes or 3. This is the overall summary of the modeling approach, and I'll try to. Here's the full. You can find it, of course, in the book. Let me zoom in a little bit now. One more time, I think. And then let me. Whoa, not like that. Like this. Method box. We start out by data. Maybe, not bad at all, having some physics, mechanics, engineering, dynamical subject matter knowledge of the phenomenon that we're jumping into. That's always good. It's not necessarily necessary, but it's not at all in contradiction with what we are teaching you on this course to have it. Then we do the model expression. After with that, we estimate the model by R. After that, we check the model. So we have the full model here in a way, right? The full model. In a way, I put it in sort of quotes because then I actually maybe even do a larger model later. But in a way, including all possible x's. Then we check the residuals. That can be done either by visualization or by, and let me just make sure, or by actually modeling the additional nonlinear structures. And if needed, we have to, it's a feedback thing, right? We may have to transform, maybe log transform, maybe include more variables, maybe have some square things. We need to go on and start all over again until we have something that's okay. When everything is okay, we tell the story, we summarize, we use the model to summarize what's going on. It can be by summary, it can be, we can extract the confidence intervals that I gave you. I mentioned the method box, I didn't show it to you, that shows you how to get the confidence intervals, but it's basically just reading off the slopes, taking the standard errors, that is also part of the output, and then using the t-quantiles, and we have confidence intervals, as I told you last time, or use the conf int of R. Then something that we don't have time to really do much about in the course, apart from what about collinearity, as I discussed at the end. Our tool in this course is to simplify models, look at the backward selection, maybe study the interrelations between the x's, of course. That's a good tool to understand if we have an issue or not. Then there are tools, and that's the link to the rest of the life for you. There are tools to deal with highly dimensional X data. And I mean, such X data can be hundreds, thousands, millions. If it's chemical spectrum, if it's pictures, if it's pixel values in a picture, it can be, or if it's expression data, whatever. It can be really, really huge, this dimension of X. With huge dimensional X, we need andere Methoden, yeah? And one of those methods that just pop up here in a small part of the course is called principal components analysis, the most classical dimension reduction technique, or variations thereof, of which there are many. So such techniques are inherently part of also machine learning or other multivariate techniques for data handling. If you go towards image analysis, medical image analysis, signal treatment of signals generally, you will need to deal with such dimension reduction techniques. PCA is one of them. So you could decompose or sort of dimension reduce your x's and use sort of derived x inputs rather than original x inputs to but then now we're on to later in life for you. In this course, we do the classical stuff for now. Having the final model, we can also do, as I showed you at the end, predict. And predict, we can either estimate with confidence interval, or we can predict new observations if that's the interesting thing that we are facing. So that's the overall picture of what you've learned actually last time and today in a single method overview. We need to find a winner and be prepared, because there's a really easy question, so be rapid on your hand there. Last question. Guess the correlation. I have high expectations this time. For the first time ever, we're gonna see perfect fit. Maybe. If I also manage to do it correct myself. Well, we're living in life of variation, so this is pretty perfect to me. Let's see who the winner is. Would Nice Face like to be applauded? Good job, Nice Face. What about Fat Tyr, friend? There you are. Good job. And finally, Sorrow Mellow Mike, you were number one, but would you like? Good job there also. So good to have been with you again. We have a few times left, so see you next week and enjoy it out there.